Let's study how the arguments of the function call is passed to the function definition. We have two mechanisms in C++, that is pass by value versus pass by reference is the mechanism. So let me define a function to illustrate this one. Void do with the value. Then let's define integer variable n. Then what I do is I store 10 into n. Then let's define an integer x, which is a 5. Then let's call do with the value and then pass x. Then what we expect here is that assert we expect x is 5. And then let's see that what if I change the variable name into x? Still the same thing happens. So if I compile and then do with the value, the prototype is not given yet. So let's give a prototype void do with the value and integer is there. Make, run the program. Then this assertion is a success. So what's happening is as follows. So if I draw the variables in the computer memory, the local variable x is defined here in function concept function. So x is storing value 5 by this statement. When you call do with a value, there's another area where do with a value function is defined. The function parameter is a local variable to the function. So this variable parameter named is x. So when you store 10, 10 is stored here so that when you done with the function call, come back when you have a reference to x. Since this is a function concept of a local variable, so this variable is used. So even if you give a same named variable in do with the function, physically they are different. So that there's nothing happens as you update the parameter in do with. So we can trace the program execution using the debugger. So in the debugger, let's set a breakpoint here, run the debugger. So at this moment, x is not initialized yet. Step over, x is a 5. And then if I do step into, now local variable x is within this scope only. The variable x in the function concept is not appearing there. Now the value 5 is passed into x by the function call. That's why currently x is 5. Now if I do step over, x is updated to 10, but that is in this local function. If I now step out, the local variable x in the function concept remains 5. That's what's happening as we investigate by drawing the memory picture. Let me stop, and then let's define another function. So void do with the reference, and then define m like that. So when you define parameter with the ampersand after the type name, that is called the reference definition. What this does is as follows. Now let's call do with the reference with the x, and then if I try to assert x is 5, it will fail. So anyway, let me terminal, let me compile. Let's do with the ref. I need to define prototype. Void do with the ref, and then this is an integer reference type, so we need to give an ampersand there. Now if I compile and run the program, assertion fails. So this is not 5. Instead, this is 10. If I run the program, now assertion is successfully done. So the value of x becomes 10 instead of a remaining 5. What's happening is the definition of the parameter. If you give ampersand, we call this as a reference variable. Reference variable means when the function is called, the variable used in the function call is passed as is, not just a copy of the value. So if I draw the picture in the computer memory, so at this moment, variable x is defined in a function concept function. When you go to the do with the reference function, the variable m is not declared when we declare as a reference. So variable m is not declared, but the original variable x, which is passed, is simply available in the name of m. So m is a kind of alias or nickname referring to the original variable x. So if I assign into m, then since we don't have any physical variable for m, 10 is assigned directly into the original one. So this function is a reference to the variable in another function if you pass the variable as a reference. So to do so, we simply attach the ampersand after the type name when you define a parameter. So let's trace the program execution. So let's go to the debugging mode and run again. Now let's do step over, step over, step over. X is a 5 function concept function. If I step into variable m appears as m, but it's just the alias. If I do step over, m is 10, and then if I step out, now x is updated to 10. So that's a pass by reference mechanism. So pass by reference, in a summary, define variable parameter using ampersand, then you are not creating new variable within this function, but you simply have a reference to the original variable x. But in this function, the variable x is called m as an alias. So whenever you use m, it's the same as using variable x in function concept.